Hello everyone and welcome to the distribution team demo. My name is Robert and this week I'm going to be demoing the current state of the GitLab Orchestrator, and what we're going to do is install the 2K reference architecture. So let me go ahead and share my screen. I've done a little bit of pre-setup here. As you can see, this is just the 2K reference because this is nothing really new has changed here since the last time I did a demo. We get our machines with the various and sundry addresses. And it's going to kick off orchestration. Now, some notable things that have changed. Let's go from here and go over to a. All right. So, some things that have changed. We now, thanks to Dustin, we will idempotently install licenses. So one of the things with GitLab licenses is that typically you put your license at the beginning, and then if you want to upgrade or do more later, you have to go into the web UI and update it. If you're trying to do just regular unintended installations, a lot of folks seem to have the pattern of when we do a release, they do an update, right? So if you're getting a new license, you want to have that just be part of that process. This is now possible. So that's one improvement we have for the user experience. The other thing that we have done is we've made some discoveries along the way. For one, we figured out that the max wall senders, there have been random issues that pop up every now and again when running pipelines. Let me stop sharing my screen for a second. So there have been random issues in a pipeline where you run a pipeline, and you do it the first time, and you stand up, say, geosecondaries, and you'll get this message saying, hey, I can't do that. And the number of wall senders is actually, you increase the number of wall senders, and you keep increasing it until it seems to work. But the documentation all says, have your number of nodes plus 1. Well, the answer is that's not quite right. And what goes on is that when you do that initial replication, there's a PG backup upgrade. And that doesn't take 1 slot, it takes 2. So for as many geo sites as you have in addition to your primary site, you need plus 2 extra slots to handle that first initial replication, because when they all start in parallel, you'll have your number of replicas in the primary site plus the number of geo sites you have by 2 plus 1 slot required, which is not transparent in either the Postgres documentation when you go through it the first time or in our documentation. So we now have addressed that issue. And that's going to stop some of the strange, why did my databases intermittently fail? And it's all about the timing. When does those 2 slots get made and taken out? Because if they happen too quickly, you get a problem. The other thing that we have fixed in the current release is we discovered that when you spin up application nodes quickly, there are settings before you do database migrations that get encrypted into the application settings of GitLab. And those encrypted items, if 2 application nodes come up at once, the first one wins. So if it's not application 1, which is where we're going to run all of the database migrations, everything fails from then on because the encryption key to the database has changed, because it puts the encryption key for the wrong node in before it tries to run the actual database migrations. So this is a thing that we've learned. Stan is going to be looking into that more, and we're going to see if we can get rid of that whole set application settings. Set something in our database even though we have database migrations turned off, right? Because that's not really expected behavior. So that's something else that we have learned in the past cycle. Go back to sharing my screen. Now, as you can see, we're doing the load balancer. And what I wanted to point out, now there's an interesting thing when you do a load balancer, okay? The machine comes up, its default port is port 22 for SSH. But when you put a load balancer in front of application nodes, one of the things that you have to do is reroute SSH traffic so that when you do a git clone or a push, that traffic actually hits one of the application servers behind the proxy. Well, the machine already has 22, and HProxy isn't going to help us do that trick where you send back to override SSH. So the way we've gone around this is that on the HProxy, when this machine comes up, Orchestrator auto detects and says, what port are you using for SSH? and it figures it out based on the configuration. And if it doesn't have both ports, it knows it's not configured right yet. It stays on port 22, logs in, does the package installation, and then switches so that after everything is done, you'll log into SSH, the actual SSH of the machine, on port 2222, and port 22 is going to redirect to the machines. And every run of Orchestrator after this will detect that change and intelligently figure out whether it should be trying to run Ansible jobs over port 22 or port 2222. So that's just kind of a nice baked-in feature, so that you don't have to worry about, which one is it when I set it up, and also keeps it idempotent so that job can just run over and over and over again from the first time all the way to like the 30th time. So, and that is one of the things that's been added. So since the last time we showed this, last time we did ticket architecture, we could just really provision the nodes. So we've added everything except for buckets, which means that we can now set up Giddily behind the system. Both applications nodes set up and set up successfully. The database sets up correctly. The Redis sets up correctly and starts using Redis caching. And the load balancer properly stands up in front of the two application nodes. So we'll actually be able to connect to this architecture the correct way, which is through the load balancer. And then also there's some interesting features of load balancer that I wanted to share as soon as it gets to where it's running. So let's see where we're at. You're on database. Might be able to do something like this. So let me just go take a look. 1, 2, 3 from the bottom. Okay. All right. So one of the other cool things, thanks to Gerard, that I found out about HProxy, is that you have this interesting interface at port 1936, if you expose it, that shows you what's going on for HProxy on the load balancer. So I found this invaluable because this tells us what all listeners are. Oh, we also have monitor now. So when we get this up, we'll be able to look at monitoring for the cluster as well. But we're able to see that right now, it can actually get to the endpoints on the application nodes. Now, it's not done configuring, but we can see that, I'm sorry, the SSH on the end node. So we can see that it can now connect on SSH, which is good. And we're waiting on the actual Rails app, which is going to be more configuration. But this gives us a great overview to know if our cluster is healthy or not. So I just wanted to share that because I found that to be a really awesome tool. Again, thank you to Gerard for sharing that because I hadn't seen that. So we're still going. Let's see. All right. So I've done a lot of talking and a lot of showing. So I'm going to pause for a moment and open up to the floor if anybody has questions, comments.
So I do have one that stands out, and the question is, what are we doing to better document the not quite spoken things in regards to the database? Obviously, in our case here, we're standing up a lot of the infrastructure all at once, and eventually other people will be able to make use of this functionality as well. But we need to make sure that it's well documented, that if you already have a primary in place and you just suddenly want to add 2 geos, exactly how many slots you need to make sure the primary has before you do that. So.
Yep, I'm working on that as documentation MR as we go through. Let me pull this up here. This is, so as I go through with these, one of the things that I do is I go back and do stuff like this. So one of the secondary aspects of the Orchestrator project is everything that I find, I go back to the reference architectures and the geo pages, and I go back and I add. Like for here, one of the things that wasn't clear is that the 2K architecture doesn't talk much about why you do NFS, and it says NFS is optional. But what it doesn't tell you is that if you don't do NFS, you need to set up fast keys, because NFS is how authorized keys for when you set your key to the UI, that's how all the different application nodes know how to connect. And so you'll get random doesn't work or does work Because the load balancer will either send you to the one where your key went or to the application node that doesn't. So you have to set up fast keys if you don't set up NFS. And since we're deprecating NFS, fast keys is becoming default. So this is an MR that adds that information so that the reference architectures, when you go through it, you're left scratching your head going, why did this not work? Why is it work intermittently? So this is one of them. The other one that's going on is in the geo side of things. So if you run a license check on a geo secondary, it'll say geo won't work because there's no license. But geo doesn't need a license on the secondary, it only needs to be on the primary site. So I have updated the rake task at this point, and it's still going through review, but updated the rake task to actually check that correctly. So that's just a couple of ways in which, as we learn these things, they all get folded back into our mainline documentation.
Right, and for reference of other people, we've been turning on the fast keys or the fast SSH key lookup by default as part of the cloud native pretty much since inception for this particular reason. And in reality, there's pretty much no reason not to do that anyways. Early on, we were concerned about, performance difference and stuff like that, but there's just no point. The fast keys lookup is so performant that it's not impactful, and actually at scale, it's more performant than NFS itself. So that's a great example of something that we just need to call out, because the distribution team has basically gotten accustomed to large-scale applications just having it on, and we're like, oh, we have to tell people to do that. Duh.
Yeah. So that is So there's been a couple of things learned. A lot of the benefit here for Orchestrator is that we're learning about things at scale, also things in parallel, like the application settings being touched before database migrations. It was kind of sort of quasi-known, but the large-scale implications of it was not. So things like that, or with massive parallelization and standing up of Omnibus, is calling out issues. The other one that came up, make it open. It just recently emerged, is this pgbouncer running method. So what we used to do is we used to run a status, but if you couldn't connect, you'd get an error. So what we do now is you could get an error state after, because the service could be there but not listening. Like there's this gray zone between when the service for pgbouncer starts and when it's actually properly listening. And the check was saying, are you started? But it did not necessarily imply, and you're listening too. So because of that, we now, pgbouncer running now does the check in such a way that it checks for both, right? So we never let this run where you're not actually listening, right? Because that's frustrating. Okay.
Right, so that's basically implementing, for context of others watching, that's effectively implementing the readiness probes that you would find in Kubernetes or the various container orchestration platforms. We were doing a liveness probe, but by just going, is it running? But we weren't actually doing a readiness probe by making sure that it's listening and actually able to respond. So this brings everything into line.
Yep. And that work went into Omnibus. So folks that have already written their orchestration, they know some large sites have already done some automation of their own. This will help them with their automation as well. So, and a lot of this, we're trying to fold things back so that this is for folks that have already done all of the work to automate. We're going to put this goodness in there so so those folks can take advantage of it. Because if you already have a solution in place, Orchestrator adoption, you might, but it's a long project. This gets some benefit into the hands of those folks today, right now. So, and that's kind of the other goal, right? Is to, not some folks won't use Orchestrator simply because in their environment they have to use the things that they have by policy, by whatever. So we're trying to fold all these improvements back for them as well. To that point, while that still installs, the other thing that we are working on right now is the concept of putting in rake tasks to accomplish some other things. So this is a small proof of concept that I worked on. It got done last night. But the idea is that when you migrate, currently the orchestrator, when it runs on a multi-database, or in any database, you can run it once and it'll configure, but then the second time it'll break, so it's not idempotent. With this, this is a rake task that will detect, have I actually run or not? Should I load the database? Should I run migrations? And it just gives us back a simple change or false. Still going through the process of talking it through with the database team reviewers, but this is kind of where we're heading. And this rake task will be available to anyone. And we're going to take what we did with licenses that Dustin did for us with licenses, and we have a similar ask in charts. So we're going to take that logic we have for licenses, turn it into a rake task, and be able to share that. So that's just a couple of things that are kind of things that are popping out in Orchestrator, and they're going to keep getting folded back, because really Orchestrator and charts have a lot in common as far as some of the problems we're solving. So we're going to try and double up wherever we can so that everybody benefits. Here. Okay. Now here's another thing to talk about. We still have to do this thing where we copy the GitLab secrets JSON file around. And that is because there are certain secrets to get made in that file that have to be on every node. It would be better to do that declaratively. And there's just a couple of things with that. If you do it declaratively, then those secrets live in the GitLab RB. Now, there's still plain text in the GitLab JSON file, the GitLab secrets JSON file, but that is the thing we're trying to identify. And there we're done. So everything is running. So let us come back to our HProxy. And I'm just going to take that port off. Okay. And I'm going to stop my screen share for a second while I grab my password. Okay. Start my share again. Now this is the same IP address that we had with the HProxy. So this is hitting the load balancer, and we can see projects. What are your projects? So let me fire up the terminal over to the side. My settings, SSH keys. Key in there. So we can see that we're here. Let's make a new project. My test. Sure, we'll make it nice and pretty. Public project. And everything is up and running. Is there anything else as far as kicking tires on this that folks would like to see? Is it a pretty bog standard GitLab?
Is this, sorry, I missed, is this one a Geo instance?
It is not a geo instance. This is the tooth-K reference architecture. So actually, no, I haven't actually looked at this. I've done it all through the command line before. So let me go to the admin. Is there a way in here to look at like see Redis and Gitaly?
To some degree, if you scroll to the right and then scroll down. Okay, yeah. What little you can actually see here is Rails, your Ruby, Postgres. It doesn't actually show you Redis here, but you can hit Gitaly servers, and it'll actually show your configuration for Gitaly servers. If you go to jobs in the navigation menu just above Gitaly servers, that actually takes you, I wonder if they moved it. Maybe they did. at one point, and it's probably still floating around somewhere, you actually had the ability to get to the Sidekick administration status page.
I think that's under monitoring.
Is that our monitoring now? Yeah. So go to monitoring and then background jobs. There you go. Just, this is the actual, like, we're doing an authorized pass through directly to Sidekick through the Rails console, I should say, directly through Rails versus through Workhorse. And we're actually checking the status of Sidekick and its integration with Redis. So we can look at it, how busy they are, how many clients they are, how many things have failed, or things like that. It's one of those points that a lot of people don't realize is actually a way to see how that is behaving.
Yeah.
So future notes and demos is if we want to load Sidekick with a whole bunch of work, whether it's running GPT or something like this is a good way to watch how those components are actually holding up to the load.
So let me come over to projects, your projects here. I can go on with SSH. So I'll bring okay. So now if Git SSH is working as we expect, there we go. So you can connect your Git SSH, you can clone, you can push. So that proves out that the load balancer out front is working and going through. So that is all I have for the demo. I'm going to stop sharing my screen. Are there any other questions, comments, concerns?
I'm not hearing or seeing anybody fighting with a mic, so I'm going to go ahead and say thanks for the demo. And anybody has questions, we know how to do that. I will wrap this up. Thanks everybody for coming, and I'll get it posted shortly.